Oh, hello. I didn't see you there. As you may already know, this is a video tutorial on helping you prove geometric statements. My topic is angles and triangles. Later on in the video, I will be giving one problem, my strategy on how to solve this problem and prove this problem, as well as my two-column proof at the end. Let's begin with our figure. On screen right now, you may see our figure. We have triangle ABC with angles 4, 3, 2 respectively. We also have angle 1 located outside the triangle. Now let's look at our given. Our given states that angles 2, 3, and 4 are interior angles of the triangle ABC. Lastly, let's look at the statement that we need to prove. We must prove that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Before we can start proving, we must first devise a strategy or plan. We must be safe with our proof. That's why in Geom, safety first. Let's plan. Our strategy contains postulates and theorems that we're going to need to prove our problem. The first theorem on the list would be the triangle angle sum theorem, or the TAST. Next, it would be the definition of a linear pair. And since we're using the definition of a linear pair, the linear pair postulate can also be applied, or otherwise known as LPP. Properties such as transitive property may be also used here, as well as the additional property of equality. Now that we have our complete strategy, we can use these postulates in theorems and definitions, as well as properties, to prove our statement. It's time to prove. To help us prove, we will be using the two-column proof, where on the left, we'll put our statements, and on the right, our reasons. Our first statement will be that angles 2, 3, and 4 are all interior angles of ABC, with our reason being that it's given. Our second statement will be that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180. This is because of the triangle angle sum theorem, where it states that the sum of all the measures of the interior angles in a triangle is equal to 180. Our third statement will be that the angles 4 and 1 are a linear pair. We can determine this because of a definition of a linear pair, which is our reason. A linear pair is a pair of angles that are adjacent and supplementary. On to statement 4. The measure of angle 4 plus the measure of angle 1 is equal to 180. This is because of the linear pair postulate, where it states that the sum of the angles in a linear pair must be equal to 180. From here, you can notice that there are two equations equal to 180, one from statement 2 and the other from statement 4. With that knowledge, we can get our statement 5, where it states the measure of angle 4 plus the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. Since both sides of this equation is equal to 180, we can equate themselves to each other. This would be called the transitive property, which is our reason. The sixth and final statement states that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. How did we get to this, you may ask? Well, we added negative quantity measure of angle 4 to both sides of the equation in statement number 5. This specific property is called addition property of equality, which is our reason. As you then can see, in statement 6, the equation is equal to what we are asked to prove. We are finished. Nice one, team. Good job. High five. Here is a picture of our complete proof, from statement 1 all the way to statement 6, along with the reasons on the right side. Well, that's all for today, and I hope that you were able to learn something from this tutorial. Thank you and goodbye. Bye!